Okay, hi everybody. Today we're going to be using AWS to essentially convert our files to a URL that can be then saved in our database. So to start off, we have our base 64 converter, which essentially takes in an image and then converts it into this really long, confusing string. So here's an example. Oh, thank you. Shingo's computer again. Okay, so here we have this image of me and Shingo, and we're gonna use this to then convert into an URL to be saved in our database. So what we do is basically just drag and drop this image to be encoded, and what this website is doing is encoding it into Okay, success. Yeah, basically this website, it essentially encodes our image into a string that can then be basically sent across the network. So we can show this here. We just copy our image, and then let's just paste this here. Oh, control. Okay, so then basically we have this really long, confusing string, which essentially encompasses all of the data that was present in this image. And so if we send this request, we're going to get this URL. So now let's, oh, what did I do? Oh, okay. Basically, I wanted to, okay. Where's the, oh, my bad. Okay. Yeah, my bad. Okay. So basically, this is an URL that represents our image. And now if we paste this into our browser, we can now see an image that was downloaded. And when we open it here, we're given that same image back. So basically what we just did is we encoded the image, and then we ran a program, and then that image was converted to an URL. We open that URL, and now we have back our image. So now what we're focusing on is basically creating that program that allows us to convert our image from that really long encoded string to the URL that was that's basically going to be stored in our database. So to start off, we're going to go to Amazon AWS. So, okay. So, and what we're going to do is essentially go to products and then go all the way down to storage. And then, storage. And then what we want to choose is S3. Here we go. So basically what you can think of is Amazon AWS, specifically S3, it's going to basically allow us to store our images in a certain way. So now let's just get started. Okay. And now what we want to do is basically create a bucket. And again, as a bucket is basically like kind of like a container that stores our given images. So now let's get started creating a bucket. So let's just say bucket name, let's just say demo 8. Demo 8 real, because it's for real now. Okay, and then we select our region. We're in US East. And then what we want to do is essentially choose ACL enabled. So basically like, yeah, we just want to choose ACL enabled. And then we want to turn this off. And then we have to acknowledge that we want to turn off. Like basically it's allowing public access to this image. And like in certain contexts, you wouldn't want public access, but in context of our course, we do want public access. So we're going to turn off this and then acknowledge that like we're making this decision. And then we're going to create our bucket. Okay, so now we have our bucket that's created to be used with our images. Okay, so then now what we want to do is go to our profile username and then go to security credentials. Because basically, as if with any program, you basically need some form of credentials to like basically say like, okay, this is actually me, I'm authorized to do this. And then I'm authorized to do this. Essentially, you want some way to credit who you essentially are. So then we just go to access keys, and then we're going to create a new access key. And then what we could do is show the access key. So basically, like in a real world setting, you do not want this accessible to anyone, because if you have this access key, you then have access to your AWS account. So after demo, Shingo should probably delete this access key. But in context of our demo, this access key will be used as a form of credentials for our AWS S3 server. Is everybody following? So that's what we've done so far. We've created the bucket, and now we're utilizing these credentials to access that bucket. Okay, so now going to our code. Oh, yeah. Okay. Yeah, so now going to our code for today. Also, if anybody wants to follow along with the demo today, like the coding portion, you can just go to the app.py website. Ooh. Just go to the textbook website, demo, and then the starter code is available here. Is anybody interested? I'll give anybody a few minutes to download it. Okay. Is everybody ready? Is everybody downloaded the starter code? Those who are interested in following along? Yes, no? Yes? Okay, awesome. So now we just like walk through the code we have today for basically essentially creating that program, which takes your image really long string to then create it to your URL through AWS. So we have our app.py, your basic, success response, fail response, and then upload. That's going to be our main function in app.py, which basically just like uploads the image to AWS given like the base 64 form. Again, the base 64 is like the really long, confusing string. And then in our DB file, pretty much empty. We'll be working on that a lot today. And then like our standard Docker compose, Docker file for further on like deploying. Okay, so what we want to do first is essentially add the info that we our credentials to a certain file just in our project. Can anybody tell me what kind of file we want to add to store our super secret top priority information? Yes. Yeah, exactly. So now what we want to do is create a new file .env in our starter file to then store our given information. So you can start off with like the key in this scenario for S3 bucket is going to be S3. Oh, zoom in. Ooh. Okay, S3 bucket name. Is that a good size for everybody? Can everybody see? Oh, Copilot. Okay, yeah. And basically S3 bucket name, that's just going to be the name that we just gave to our bucket. So that was demo 8 real. And then we're going to have our AWS. The key is going to be AWS access key ID. And then as we can see here, that was, where'd it go? Yeah. So we have our access key ID, and then our secret access key. We just want to copy and paste that in. And then lastly, we're going to have our AWS secret access key, like the secret access key itself. AWS secret access key. And that's equal to this. So essentially what we're doing is we're basically moving our credentials from our AWS account to our .env file to be later on used. So now we've created our .env file with our bucket name, our access key ID, and our access key itself. We're now going to want to create a Docker ignore file to essentially prevent this confidential information to be uploaded to Docker. So we're going to create our Docker ignore, and that's going to contain our .env file, our PyCache, our our PyCache, and I think that's it for now. Okay, so these files are going to want to ignore. Oh, and then one last thing to do, we also want to ignore our database. So to see what the name of our database, you can just go here and see that it is, images.db. So in previous assignments, we saw some students basically putting the wrong database file in the Docker ignore. You can just see what the name of the database itself by going to your app.py and see db_file name, and that's the name of our database that we want to ignore. Okay, so now that we've done all that, we've put in our credentials, we've ignored our credentials, and now we want to start working on our db file to essentially create this program to, again, convert our image string to a URL in AWS. So first off, we're basically going to import a lot of stuff. So First of all, we're going to import base64. That's the program that does the conversion. We're then going to import Bodo. Oh. We're going to import Bodo, which is basically a library that is used alongside AWS. Then going to import datetime, and then datetime is essentially used to like, oh, sorry. We're going to import Bodo 3, which again is a library that's used with AWS. We're then going to import datetime, which essentially like you're going to have a created at attribute for your image, a created at portion for your image. So basically say, okay, this image was created at this time, so you need datetime for that. We're then gonna import IO, which is essentially like input output. Then gonna import from MIME types. We're gonna import something called guest extension. Oh, guest type and guest extension. And basically what this does is that like for several images, it can be like a .jpg, JPG, .png, .jpg, etc. And basically what this extension does is basically guesses what the extension for you. So it handles that. We're then going to import OS, which essentially handles your secret credential stuff. Then gonna from PIL, we're going to import image, which is essentially an image object that's understandable by Python. We're then going to import random. So that's used to basically create a randomized file name later on for your newly created image. And then we're going to import RE, and then we're going to import string, which essentially is just used for like string formatting. So again, a lot of imports. You can just like copy them down when you're doing the your image implementation yourself. It's like a lot of stuff that's a bit confusing, to be fair. Okay, so now we have all our imports handled. We're then going to want to start with a couple of constants. So a couple of constants to start off with, we can have something called extensions, which is, again, basically a list storing all of the possible file types. So as I mentioned earlier, we can have like .png, we could have a GIF as a image name, a image extension. We could have a JPG, and then we could also have a JPEG. So again, just a list of like all the possible image extensions. We're then going to have our base directory, which is essentially used when locating the location of your image, like basically dealing with the location of your image, as Shunko mentioned in lecture. And that's basically just os.cwd, which is basically like your operating system, and you're getting your current working directory. So like in previous lectures, we mentioned like print working directory. It's like very similar, but it just gets your current working directory. So we have our base directory, and then now what we want to have is our S3 base, S3 bucket name, and then that's just stored in our secrets file. So that's supposed to be os.environ.get, and then that's the key is S3 bucket name. So from our secrets file, we're getting our bucket name, and then we want to get our base URL for S3. So that's going to be we're creating the variable S3 base URL, and that's going to be F. Okay, this is a lot, but HTTPS. So that's like the beginning of our URL, and then it's going to be S3 bucket name. Oh, let's name this bucket name, and then our S3 base URL is going to be HTTPS S3 bucket name, and then it's going to be .s3. Okay, how S3 .us-east-1 Amazon AWS.com. And where we got this from, that's okay, I'm missing something. Okay. Yeah, where we got this from was essentially from, I can close this now, but from our bucket, where is she? Okay, from our bucket, we have this this region, and then basically if we look at our Postman, it has this base URL S3 US East 1 Amazon AWS.com. So basically every single image from our given S3 bucket is going to have this base URL. So that's what we're creating here. So basically our bucket name and then this like weird s3.use blah, 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 blah. So that's essentially all that we're doing right here. And I think I'm missing something. Oh, yeah. Thank you. Okay. And then what we did here, basically, the weird funky looking syntax with like F and then like the curly braces. What this does is essentially instead of doing like hello plus like, remember like last lecture with like combining your environment variables and like hello JZS27 and you get JZS27 from your environment variables. Instead, you can basically just instead of doing like hello, and then like a plus sign, and then like os.envar blah 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 blah. What you do instead is do something called an F string, which is basically just F, and then you do your string, and then you essentially just do a curly braces, and everything inside your curly braces is a variable you've already defined. So what we're doing here is essentially like F, and then everything in green is an actual string, and then everything within the curly braces is a variable itself. So this is a great way to basically avoid doing like the one string plus another variable plus another string. So this is better Python syntax, which you should use moving forward. Okay. So now that we have all of those now that we have all of these constants defined, now what we want to do is move on to defining our asset class, which basically is just like a DB model to represent our image. So to define this, we're just going to do class asset, and that's going to be a subclass of our db.model. This should be pretty familiar. This should look pretty familiar from lecture 4, I believe. So basically what we're doing here, some documentation, we're setting up our asset model. And then very, very similar to what we did in the past, we're going to set up our table name. And that's going to be, asset. And then we're going to basically do our basic database model setup. So that's just going to be db.column. And that's going to be our ID is db.integer. Yeah, db.column, db.integer, primary key equals true. Auto increment equals true as well. Okay, now we're going to define our other other columns for our asset model. So we're going to have like base URL. That's going to be equal to another column. It's going to be a db.string. URL is a string. Notable equals false. Okay, to be fair, we're going to define like a lot of columns. So salt equals db.column. And then salt is again a db.string, and then that's going to be notable equals false. Notable equals false. And then at this point, we can just like start copying and pasting because it's going to be like a lot of different columns. So then next we have, oh, that's not what I copied. Okay. Oh, okay. The next one is going to be extension. So the extension for our image, that is also going to be a extension. That's also going to be a string, nullable is false. Next we have with db.integer this time, integer, then the height. So a lot of boring copying, pasting, fun. Integer. And then lastly, we have created at, and then that's going to be, the type of this is going to be db.datetime. So this is basically just like a built-in type from a built-in type. Okay, so we just defined all of the basic columns for our asset model. So then now we're moving on to initializing it. So that's def __ init. That's going to take in self and quarks, our keyword arguments. And then this just little documentation initializes an asset object. Okay, And then basically what we're going to do next is we're going to have our init function call a different function. We're going to have it call self.create, and then keywords.get image, image underscore data. And now let's define self.create. So def create, that's going to take in self, create, that's going to take in self and the image data. So the image data we're referring to here is the same image data that this long string that we dealt with earlier. Okay, so now we have create, and then our create function is gonna do 3 different things. So basically it's given an image in base 64 encoding. So again, that's a long string. Does the following. Step 1, it's going to determine if the given extension of your image is valid or not. So essentially it rejects the image if it is not a supported file type. So basically, like if we only supported PNG, GIF, JPEG, JPG as earlier. So say you send in like a .mov or something, it'll like reject that. Step 2, it's gonna generate a random string for the image file name. So as we can see earlier, our inputted image name was backend baddies photo.png, but when we downloaded it, where'd it go? Oh, thank you. Yeah, when we downloaded it, it's this like very weird random 16 character name. So it went from backend baddies PNG to whatever this is .png. So that's the second step in our encoding. And then the last step is going to be decodes the image and attempts to upload it to AWS, so like our online service. Okay, so first of all, we're going to define our function in a try catch statement. So basically, if like for whatever reason AWS like goes down, like Amazon is broken, our app doesn't break because of this, because we'll have a try except statement. So try pass except exception as e pass. Why is it? Did I spell it wrong? Oh, exception is e pass. Okay, so we have our try statement and our except statement. So the whole point is, as I said earlier, if Amazon breaks, our app doesn't break. So to start off, we're first going to get our given extension, and we're going to reject this if it is not a like supported extension. So that's going to be ext. The given extension is going to be guess extension, guess type, and then we're going to basically parse our image data. The syntax is very, very weird. But basically we're parsing our image data to get out our given extension, to get out the provided extension. And then these two libraries are basically going to deal with that for us. Okay, moving on. So we have our extension now. So now we're going to check if it's an invalid extension. So if ext not in extensions, which is the constants, like the list of valid extensions that we defined up here, we're then going to want to basically raise an exception. So raise exception, something is wrong. F extension ext is not valid. So again, F strings, everything in green is the actual string. The curly braces red is the variable we've already defined. Okay, moving on. So now that we know our extension is valid, we now want to basically start working on the step number 2, which is generating a random string for the image file name. So to start off with that, that's going to be salt equals dot join. Okay, this again is like a very long, kind of complicated process. But the important takeaway from this is to understand that this is just produces this is what happens when this is what you do to go from backend baddies to the 16 string random file name. So system at random dot choice string string dot aside. And if you notice earlier, the random file name we were dealing with was only letters and numbers. So that's what we're doing here, like the uppercase and then the digits. So that's what's being done here. And then we do that for underscore in range 16. And all this is doing is basically making 16 characters long. Now we basically want to remove the header from our base 64 string. So basically all of this good is like basically our desired string with the relevant, thank God. Yeah, with the relevant information. But every base 64 string is gonna have this header, data, image, PNG, base 64. And what we want to do is remove it and only be left with all of that. So that's what we're gonna do now. Essentially, the first step is just doing getting the string. So that's image string. So like the core string. Oh, Ras. Actually, let me not get into this now. We're gonna we're pressed for time. So now let's just move on to the Kahoot, and we'll start off with removing the header at the beginning of Wednesday's demo. I didn't realize how late it was going. Okay. Shingo, demo.
Yeah.
Kahoot. All right. Hi, everybody. We're gonna get started with demo for today. Today is the last lecture of the semester. So yay for getting through the semester, backend. Okay, so just to iterate what we covered on Monday. So the whole purpose of images is essentially you send, well, actually, let me just show. You have, where is it? Okay, you have your base 64 image converter, and essentially you upload an image, and then it provides this like super long string that we can see here that encompasses all the image data. That image data is sent from the front end to the back end, and then the image data itself is not stored in the back end. Instead, we use an external tool called AWS to essentially store our images in these entities called buckets, and then that provides a URL. And the URL itself is what is stored in our backend. So essentially, you have our long ass string. Oh, I shouldn't have said that. Our big string. We have our big string. We have AWS saves the string, saves the image itself, and then the URL is saved in our backend. Okay, so to iterate what we went over, we used this to create our big string. And then this is like we showed a little demo of basically the URL we created. And then the program itself, which does that for us, is that we have, oh, my bad. Okay, cool. We have our DB file, which essentially we have a class asset, and the asset is basically the model that is the entity of our image that has a base URL, which we define. It has the salt, which is kind of like the incognito name for our image. We have our init method, which initializes the asset object and which calls our create method. And then create essentially gives an image in base 64 coding. It basically makes sure it's a valid file type like PNG, JPEG, JPEG, a GIF, etc. We then generate a random string for the image file name. We then decode the image, and then we actually upload it to AWS. So what we did thus far last time, we stopped at, I believe, generating the random string. So here, the salt is essentially the replacement for the file name because we don't want like image information being stored. So instead we use a random generator to create our file name. So to continue off from last time, what we had to do next was essentially remove the header of our base 64. So as you can see here, the beginning of our long string, it all begins with data, image, PNG, base 64. And the actual image information is everything onward. So essentially what we want is this. So from our string, we essentially want to extract everything else but the header. So to do this, we call this function, which is also kind of weird. When you're implementing images for your autopilot. Yeah. When you're implementing images for your hack challenge, you can just like copy this from the demo. But how we do this to remove the header of our base64 string, what we do is we're saying image string is equal to re.sub quote uppercase data image dot slash plus base 64. So like this very weird syntax. And then basically we're going to take that. So that's what's the beginning of our long string. And then what we're going to do is that we're going to replace it with an empty string. And then we're going to send in our image data. So right now our image data is like the entire string, and we're just subbing in the header for an empty string to essentially remove the header itself. Okay, so now that we have our image string, we're now going to say our image data is going to be equal to base64.b4. Where is it? B64 decode. Where is it? B64 decode. And then we're sending in our image string. So line 63, what we're doing there, we're basically taking in our image string, and then we're going to decode it into our image data, which is what we want. After doing that, we're going to create the image itself. So the image is going to be equal to image.open, and then we're going to convert it to bytes IO, sending in our image data. So essentially, we're converting our image data from binary into an image object, which Python actually understands. Bytes IO, did I import that? Bytes IO. Okay, I think it's just, did I import it? I think I should have. Yeah, I did. Oh, I didn't. Okay, my bad. From IO, import, bytes IO. That's what I'm missing. Okay, awesome. Okay, so now we have the image ourselves. It's line 65. And then what we're going to do next is basically just do the basic setup for our image object. So we're going to set self.base URL is going to be equal to the S3 base URL, which we defined as a constant up here. And then self.salt is equal to salt, which we created earlier here. And then self.extension is equal to ext, which we extracted from Monday here with the whole guest extension library thing. And then self.width is going to be equal to image.width. And now we can do this because image is an actual image object, which inherently has like the characteristic width. And then self.height is equal to image.height. And then self.created at is going to be equal to datetime.datetime.now. So all we're basically saying that the time we're creating the image is like this moment in time, like right now. And then finally, image underscore file name is going to be equal to an f string with self.salt. So that's like the random 16 character string we generated earlier, dot self dot extension. Self dot extension. So then now we have our defined image file name. And then we're going to finally upload our image. So self dot upload, we're going to define this upload function after this, self dot upload, and we're sending in the image and the image file name. Okay, and then this is all within our try section. And now just to print to handle our exception clause, that's just simply just like going to be printing our exception. So that'll be we can just print the error message, error when creating image, and then we can just like print the given error E. Oh, this should be an F string. Oh, yeah. Okay. So just to quickly reiterate, we have our try, we get the extension, we create the random file name, we set all this information, and then we finally call our upload function, which we are going to define now. So def upload, and that takes in self, and no, this is, yeah, that takes in self, the image and the image file name. And what the upload function, does is it essentially attempts to upload the image into the specified S3 bucket. And the S3 bucket is basically the Amazon service, which we are, like this Amazon, like, what's the word? The Amazon entity, which we're utilizing for storing our images itself. So little documentation. So the upload function attempts to upload the image into the specified S3, S3 bucket. Okay. Is my indentation off? Oh, okay. Perfect. Okay. So again, we're going to wrap this in a try catch statement. So try, and then exception as E. Okay, so now let's define this. So for our upload function, we're going to basically save our image in a temporary location in our computer. So basically to like upload the image into our S3 bucket, it needs to come from somewhere. And so we're going to define that temporary location as like the base directory and our current file name. So to do that, let's just say image temp location is going to be equal to, again, another F string. Another F string, and that's going to be base directory, which is a constant that we defined earlier, slash our image file name, which is sent in. Which is sent into us in the function header. Image file name. Okay. Perfect. I'm missing something. Oh, this should be F. Oh, perfect. Thank you. Okay. So now we have our image temporary location, and then we're going to save our image. We're going to save our image in this temporary location. So that's simply just image.save, and then pass in the temporary location, which we just created. Then what we're going to do is now we need to actually upload this image into our S3 bucket. So now upload image into S3 bucket. And then to do that, essentially what we need to do is create a client, which is, we're going to use the Boto3 library, which we imported earlier. So S3 client is going to be equal to Boto3.client. And then we're sending in S3 to specify the type. Now, using our newly defined S3 client, we're then going to upload the file. So to do that, or like upload the image itself. So to do that, that's going to be S3 client.upload. And this is like a built-in function of the S3 client. Upload file, that's the function, my bad. So upload underscore file. And then we're going to send in the image temporary location and the name of the bucket, which is again a constant that we defined earlier, and then our image file name. So now we've uploaded our file, and then we need to make, the last step in this is essentially make our image URL public. And a step that we did when we were creating our bucket initially, when we were setting up like on Amazon AWS, when we're creating the bucket, we specified that something called the ACL should be enabled. And the purpose of doing that is basically allowing people to like, able to like change the URL to make it public to anybody. So to do that, it's simply just like S3 resource. Resource is going to be equal to Boto3.resource. And again, Boto3 is just like a library used by Amazon AWS. And then specify S3. So now we've created like a resource for S3. And then object ACL is going to be equal to S3 resource dot object ACL. I know this like it's kind of weird, but the whole purpose of this is just to make sure that the the image URL is like publicly accessible. And what we're going to do is S3 bucket name, and then image file name. And then lastly, object ACL dot put, and we're going to put the ACL is equal to public dash read. So I know it's kind of funky looking, but the whole point is that you're able to make the S3 image URL public so that anybody can view it. And then the last thing that we need to do is basically we put the image in a temporary storage location. Now that we've uploaded it to the AWS bucket, we now just need to remove it from that temporary location. So to do that, that's just simply os.remove image temporary location. Okay, so we saved our image to the temporary location. We uploaded the image into our S3 bucket. And then lastly, we removed image from temp location. So now that all that's done, just to go over, we created our image. We then uploaded the image. And then lastly, in our app.py, we now need to basically create that as a route that can be hit later on. So looking at our, leave this up here. Oh, my bad. Okay, forgot to fill this out. So lastly, we need to fill out our exception. So that's very similar to our exception up here. We're just going to print our arrow. So print an F string, and that's going to be arrow when uploading our image, because this is the upload function. And then we can just like print out our given arrow E. Okay, so that's all we have for our db.py. And now we can start working on our app.py. And then the main function in our app.py is another upload function. And the whole point of that is basically it just being a route to hit when you're trying to upload your base 64 string. That's essentially what this is right here. Okay, so now our upload function, as it says, endpoint for uploading an image to AWS in the given base 64 form, then storing, returning the URL of that image. So we're on the final step now. So very standard, body equals JSON.loads, request.data. I'm sure this looks very familiar. And then we're going to get our image data from the body. So that's just simply image_data is equal to body.get quote image data. So now we've extracted the image data from our request. And then very, very familiar, if image data is none, we want to return our failure response. So no base 64 image found. Then, so now we have our image data that's valid. Now what we want to do is create our new asset object. So to do that, firstly, we need to import our asset object from DB. So from DB, import asset. And now we want to create that object. So that's going to be asset equals asset. And then we're sending in our image data. I said asset. Image data is equal to image data. That's because we're able to do that because how we set it up earlier with the keyword arguments, quarks. Now what we want to do is very standard, save it. We need to add it to our database and then save it. So that's just db.session.add our asset. And then we made a change to our database. We want to save it. So that's db.session.commit. Then lastly, now that we've done all of that, we need to return our success response. So return success response, sending in our asset. But since the structure of our asset is not in a way that that's understandable, we need to serialize it like any other object. So asset.serialize. And now we need to define our serialize function. And then we're sending back a 201 success code because we just created a new object. Okay, so that's all for app.py. Now we can go back to our db.py and define our serialize function. So that's going to be def serialize serialize, and that takes in self. So documentation serializes an asset object. And then that's just going to be the standard returning a dictionary with the given information. So that's just return a dictionary. Oh, return our dictionary. And then in that dictionary, we're going to have our URL. We're basically setting up this dictionary that's returned. So our URL and our created at. So that's just going to be URL, and that's equivalent to f string self. Ooh, okay, I did this wrong. F string self dot base URL slash. Oh my gosh. Okay, slash another polar base self dot salt dot self dot extension. Okay. And then, so we have our URL. That's the base, yeah, the base, we have salt, which again, salt is basically the randomized file name and then our given extension. And then lastly, we just want our created at field. So created at, that's going to be self dot, another string. We just cast this to a string. So that's self dot created at. Self dot created at is a datetime object. So we're just able to cast that as a regular Python string. So essentially we set up our upload function in app.py, and we're just finishing up making the serialized method in our DB, so it's able to be displayed. Oh, create. Oh, created at, my bad. Okay, thank you. Okay, so now that we've done all of that, we can get our server running to test this. So let me just make a new request, duplicate. So upload image. Let me rename this, upload image, new. Okay, so we have our Docker Compose file, and we're going to Docker Compose up to get this server running. So we did include we made an env file with our credentials. Oh, I should have included this in the recap, but essentially from our AWS account, we got our credentials, and essentially the whole purpose of having credentials is so that you need to basically have the credentials to upload things into our bucket so that anybody can't just like, oh, let me just upload this into Shungo's bucket. So we have our .env file storing these credentials. And now in our Docker Compose file, we need to include that as well. So that's going to be, let me define our image. So that's najima slash, okay, let's call this demo 8. So we're defining our image name. And now let's define our env file, and that's going to be .env. Okay, so now that we have our Docker Compose file set up, we're now going to build our container and then compose up. So, your Mac. What's the command?
You don't need the platform for it.
Oh, you don't need it now? Oh, okay, perfect. So that's Docker build -t, our Docker Hub username, snajima slash demo 8 dot.
Just call it demo.
Oh, my Rust.
You can just rename it.
Yeah. Let me just rebuild it again. Demo 8. Yes. Okay. Oh, okay, perfect. And then we want to Docker compose up, Docker -compose up -d. Okay, now our container is running. So now what we do, actually, let me first get the image URL. So to sorry, not the image URL. Let me first get the image data that's going to be sent into our Postman request. So to do that, all we do is you go to base64 encoder, and then I think this is the same file from last time, backend baddies. So let's copy our image, and this is going to be a very large string. So now going to Postman, we have our server URL. So let's replace this with, I believe it's localhost 8000. Is it 8000? Okay, yeah. Localhost 8000. Upload. Okay. Body, JSON. I believe this is the same one, so it should be working. Oh. Okay. Let's see.
Hey guys, sorry for the hiccup during demo. The solution for fixing this is very simple. It's two minor errors. The first one is in the create function. When we define the image string, in this kind of convoluted string that we have to pass in, the dot should come after the backslash. So that's the first fix. And then the next one is in the upload function. In line 109, instead of object ACL with ACL being in all uppercase letters, it should be a capital A and then lowercase c and L. So those are the two fixes. And so now if we build this image, and run as a container, you can see that even locally, I'm able to download this image. So hopefully that fixes your guys' problems. But if not, feel free to hit up your Hack Challenge mentor, and good luck.